Good day, students. Welcome back to our math virtual classroom. Today's discussion is about transforming quadratic function in general form into the vertex form. The learning competency transforms the quadratic function defined by y equals ax squared plus bx plus c into the form y equals a times quantity x minus h squared plus k. Let us first have some definition. The general form of the quadratic function is y equals ax squared plus bx plus c, where a, b, and c are real numbers with a not equal to 0. While the standard form or vertex form of the quadratic function is y equals a times quantity x minus h squared plus k, where a, h, and k are real numbers with a not equal to 0. Let us have some examples. Given y equals x squared minus 4x minus 10. Remember that the first step is to group together the terms containing x. So that is x squared minus 4x. We are going to enclose that in a parenthesis. So the function now is y equals quantity x squared minus 4x minus 10. The next step now is to factor out a. But in this given, a is equal to 1. So the function will still be the same. Y equals quantity x squared minus 4x minus 10. The next thing that we are going to do is to complete the expression in the parenthesis to make it a perfect square trinomial. So how are we going to do that? We are going to add a constant term. And that would be the quotient of 4 divided by 2 raised to 2. So that would become 4. So we are going to add 4 on the parenthesis and subtract on the constant term. Always remember that. You are going to add on the parenthesis and subtract on the constant term. So the resulting function now is y equals x squared minus 4x plus 4 minus 10 minus 4. Let us continue solving. Let us simplify and express the perfect square trinomial as square of binomial. So how is that? You are going to get the square root of the first term, which is x squared, and that is x, and the square root of the last term, 4, and that would be 2, and we get the sign of the middle term. Then the function will become y equals quantity x minus 2 squared. Then we simplify negative 10 minus 4, that is minus 14. Hence, the vertex form of the quadratic function is y equals quantity x minus 2 squared minus 14. Let us have another example. Y is equal to negative x squared plus 6x minus 5. So again, we group together the terms containing x, and that is negative x squared plus 6x. Let us enclose that in a parenthesis. So the function will become y equals quantity negative x squared plus 6x minus 5. Then let us factor out a. Here, the value of your a is equal to negative 1. So factoring out negative 1, the function will become y equals negative quantity of x squared minus 6x minus 5. Now let us complete the expression in the parenthesis to make it a perfect square trinomial. And that is by adding a constant. How are we going to solve for that constant? We divide the coefficient of x by 2 and raise it to 2. So in this case, negative 6 divided by 2 is negative 3 raised to 2 is 9. So you are going to add 9 on the parenthesis and subtract 9 multiplied to the value of a from the constant term. So if that is negative 9 times negative 1, that would become positive 9. So let us rewrite the function. Y is equal to negative quantity x squared minus 6x plus 9 minus 5 plus 9. Let us continue solving. We simplify and express the perfect square trinomial as square of a binomial. So how is that? You are going to get the square root of the first term and the last term of the trinomial. So the square root of x squared is x, the square root of 9 is 3, and we get the sign which is minus. So the resulting function now is y equals negative quantity of x minus 3 squared. Then we simplify negative 5 plus 9. That would give us positive 4. Hence, the vertex form of the quadratic function is y equals negative quantity of x minus 3 squared plus 4. Okay, now it's your turn. Transform the following quadratic function in general form into vertex form. If you forget the steps in solving, you could go back to our video.